Yeah. So this is the one, right? I mean, I'm pretty much for this webnet, right? It's on the phase one operation focus on the ID1, which will be start 2026 March in spring. And focus, right? The technique will be listed on the below. And especially you can see the two red line here, right? That's a kind of the it's a new. So anybody have a, I mean, beside this, anybody have any question want to ask?
Yeah,
Or
actually, can I ask a question? This
yeah,
is
yeah.
Trevor. Yeah, actually, so could you tell me the status of the um software for 3D PDF work?
Oh, you mean the 3D PDF, right?
Yeah.
The software we are working on, right? And since we still working on we can construct the rescopal space right now. Then
Yeah.
we are struggling with the how can we determine the real Brad peak
Ah,
to
okay.
subtract. That's
Yeah.
something we are we
Hmm.
are we are struggling because the people say you can use the variable temperature that study to determine the shape of the Brad peak,
Yeah.
or you can use the simulation, elastic constant, right, to
Hmm.
determine the shape of the Brad peak. So we're still working on this part. So once this part, then we're working on it, then we will continue, to use the software, which pretty much will be adapt the very long period 20 years ago, the laser program from the field carbon to try to refine the gas molecule structural dynamics with the data we have from the diffuse, 3D delta diffuse data. That's something with the plan we are doing right now. So it's a yeah, it's a long way, but we are working on. Yeah.
Yeah. Okay. Thanks.
Any other people want to have a question?
So, Yusheng, how large is the largest size of the beam going to be?
Okay, so largest size bin, right? I mean, that's very, depends what you need. Okay,
Uh-huh.
so for the capability we have a CRL, compound refractive lens. Also, we have a KB mirror. So
Uh-huh.
eventually, based on these two, right, we can go down to about, micron size bin.
Right.
Okay, and
Right.
without lost any intensity. So that's the beauty of the new upgrade of the APSU because they reduce the bin size. So we can pretty much use the total flux, I mean, total bin, the size of the flux from the bin. We don't need to cut out because normally before we use in the ID, right? You were here, right? Then we cut down the horizontal size. We use the
Uh-huh.
slide,
Oh
we
yeah,
move the
sure. It
slide
was
down.
huge. Yeah.
Right? But now you don't have to. You can focus everything in the one simple position. So you gain a lot, the power density, which is the flux in the simple position. But then I think the worry about is how the radiation damage come out.
Right. Right.
Yeah.
Yeah.
Yep.
And so I'm actually interested in the other direction. So we have these crystals with huge dynamic range
Mm-hmm.
that decompose pretty easily. So we want to use the largest beam that we can, and
Mm-hmm.
and so I'm just trying to figure out how large it can be.
Oh, how large we can diffuse? So eventually, good question, right? I cannot tell you right now,
Uh-huh.
okay, because I don't have any beam yet,
Right.
but then we can try to get it, right? And also in your case, right, you see the decompose quickly.
Yeah.
It because of air sensitivity or because of the
It's
radiation damage,
it's beam damage. Yeah.
beam damage, right? So that's something we also can try the serial crystallography, right? And take a
Hmm.
shot. If you have a large beam, we can take a beam, right, on your crystal, take a scan, right?
Mm-hmm.
And quickly, and that's another option we can do it. If it really cannot done by, small, I mean the decompose, I mean the enlarge the bin to reduce the flux, then
Right.
we can do some, small, I mean serious small molecule
Hmm.
crystallography and to get it to try to get the data, I mean structure coming out from that point.
Right. Right. Yeah, and on 14 BMC, we would try to go as large as 1 millimeter high, but that's out of the question these days, I'm sure.
Yeah, 14 BNC, I don't know because I'm sorry, right? The 14 BNC now pretty much, we cannot use
Hmm.
only in
It
the right now we can, but
it
I
looks like
can
it's dead, right? And
if
it's
you
not
want to
being
use right,
reconnected.
we can arrange for other binam, but I can talk to you. I mean I mean in the in the other time, right? We can
Right,
discuss.
right, sure. Yeah,
Okay, but another, because there would be, I think another uh best uh best binam would be the sector one. Okay,
right, right.
and go to the probably 25 kV
Hmm.
and we done, but yeah, we can discuss. Okay, if
Sure.
really cannot working, we can, if we cannot enlarge the bin and serial crystallography doesn't work, then we can have other things to do it.
Okay, great. Thanks.
Any other question for anything, right? I mean, if you have question for our, the bin line, right? Because a lot of people knew,
Yeah,
and
I'm interested in sort of the other end of the spectrum, um, where we might be working with uh, truly micron-sized crystals. And you already talked about one of the issues, and that being radiation damage. I'm sort of excited to do some work in that area. And then, and what were your thoughts on using the area detector for acquiring some um, rudimentary powdered fraction data?
oh
Mm.
yes, I mean that's the one thing we are also, a lot. I know there's a lot of users have been request because says okay, since the bin time, I mean data collection is so fast, right? They come here, right, collect some data, but somehow they have some bin time left. But they say, can we do some powder? Yes, I mean, but the powder would be not like the powder bin line, right? Because they all the optics or motor, right? They are really can go when do the scan, right? I mean, we might cannot do the as better as the powder bin line for they have angular resolution, so very very fine angular, angle. But in our case, probably it's a 1 degree or 0.5 degree at some point. So
Yeah,
do
but we
something.
can calibrate it with using GSAS.
Yeah, that's
GSAS
something you
2
can do
will
that. Yeah.
allow you to characterize your detector and that setup.
Yes. Yes. Because the area detector somehow, it's a 172 for our Pilatus, right? Too big.
Yeah.
Right? That's another sense. But then the
Mhm.
new detector we have,
Mhm.
Pilatus 4X, right? It's a 150 micron, still cannot comparable with the
Mhm.
Eiger 75 micron.
Right.
Hmm.
That is something, the disadvantage for the detector in our end.
But it's also 233 by 245 millimeters across, so you've got a much larger area,
Yep.
right?
Pull
Yeah.
it back. Yeah.
But maybe, if you bring this on, we do have some Eiger detector, but it's not a high energy one. So we might can use for certain things, but not a really kind of a PDF or something
Hmm.
to study. Okay, that's just something. Yeah, I can keep in mind, and if we really people demanding the user community demand stuff more and more, then we can think about and try to for next proposal, like get an Eiger detector for certain things. That's would be the good, if we can provide some study case and the scientific case we need it.
Right. So if we were going to do a round of powder diffraction experiments, how would you envision the geometry would be? Would we pack these in the small capillaries, or would we just make a ball?
Because we can do,
freezing?
I think so we can do both the GSAX, right, from the surface, or we
Yeah.
can do the transmission, right? That like you said, the cap, I mean, pass through, right? So either way, right? And
Yeah.
now we can do both because our diffractometer, we have a XYZ, translation, right? Also have a phi. So it depends, right? That depends on what it need. But then, of course, I mean, if the user community is bigger, then we can focus and starting how to write a program to dissolve and, based on our geometry to try to recover the data coming out, right?
Yep.
So that's something, yeah, we can discuss in the later on. Yeah.
Yeah, well, it sounds exciting to be able to have this sort of flexibility on one beam line.
That's right. That's right. Because especially for the crystallography, right? That's our goal, right? Because we have a large, energy, tunable energy, and also we have a lot of, the diffractometer, and then we try to get it. We have a different kind of detector, so it would be, nice see how to can, fit everything to our user community, right? I mean, that's a goal for the ChemMatCARS. Yeah.
Yep. Thank you.
Yep.
I have another.
Sorry. Yeah. Yuxiang, so will you also be accepting mail-in samples for just the crystallography for structure determination of small molecules?
If you see the phase 2, right, on the screen, right? I mean, unfortunately, we cannot do right now because the whole thing, right? If we do it, so if we would do it, the mailing will be on IDB, right? So IDB, you can see the LOBA and another diffractometer for the resonant diffraction. This is for LOBA, but then we cannot use it until the round 2, 2026. Okay, that's a bad. I want to get this one up, because million service and the remote data collection, I think that we can help the community, for those people having no travel money, having no, and really need it for the scientific, the purpose, right? But of course, I mean, also the robot not only for the mailing service, right? When you come in here, right, you have a more sensitive crystal you can mount on site, right? Coming out 1 day earlier, then you mount it, then put it in. Then next day you collecting data. You don't need to mount it. You just judge the quality of the crystal, the data, right?
Sure.
Continue to collecting data, get a good data back. That's something another for the mail-in service or LOBA data. Have a LOBA that's useful. And also, I know people ask you, do we have a glove box? Yes, we do. I just purchased one and we just set up, running nicely. And yeah, so we have a glove box for the more such, air sensitive compound, everything, then get it ready for the user.
That just dovetails what a question I have on the extreme condition experiments. So high pressure. So are you gonna provide facilities for example, indenting gaskets, not indenting gaskets, drilling gasket holes and with having microscopes to load samples?
No, right now, right? I have
yes. Yeah.
Right now I have a full diamond envelope, right? Then yeah, I will. I mean, I only probably belong to the experienced user.
Okay, I get it. that says everything. Okay, I understand. Okay.
Yeah, if a no experienced user, then we need to get it. We need to discuss a little bit more.
Yes, I understand. Okay, thank you.
And is the high pressure work done at low temperatures as well?
Good question. Good
That's
question.
a good question, right?
Yes.
Because I think so. I mean, they are
Yes.
working on the low temperature cell,
Yeah.
and I don't know how the opening, angle, right? I think so certainly
Right.
working on, and they pretty much working on for the powder. I don't think that they're working on single crystal. I have to double
Okay.
check,
Yeah.
right? And yeah, so that's something good question, right? Because it's hard to make a low temperature diamond ever cell because everything connect to, go to adapt to the play or something else, right?
Yeah.
And then some people were using the open flow to cooling down the diamond ever cell,
Right.
but
Right.
you got a lot of ice, right?
Yeah.
So that's something,
I mean, there are commercial ChemMatCARS systems for diamond cells. I mean, this DAC Tools company makes them.
you think so? Yeah, I don't know
I
because I
know.
didn't follow up. So
Yeah. Okay.
you probably can send me the link, I
Yeah,
can
I will. Okay.
Okay.
And what's the opening angle in the diamond anvil cell?
So we have a 120
Hmm.
and 85.
Okay.
Okay.
I
So
see.
that's in our, but the 120 one probably cannot hold in the high pressure.
Okay.
And the low and the 85 probably if you go to gas loading, you can probably go higher.
5.
But normally we don't want to compare it, to compare it with our brother cat, GS cat, right? And
Yes.
very high
Yes.
pressure. So we
Yeah.
just normally go down to the below 10 gas bar, for the week because I think so chemistry wanted the good structure.
Yes. Yes. Yes.
And not just
High pressure.
fuzzy,
Not just high pressure.
and like a mineral, right? You can get a structure, it's okay. But
Yeah.
I think I want to have a good structure to get
Yep.
it to determine the property of the crystal or something
Yes.
and the
Yes.
molecule. Yeah.
I agree.
So
Any other question?
yeah, so when Sector 15 is fully operational with both Beamline 1 and 2, we're expecting to have both Beamline to be capable for microcrystal crystallography.
Yeah.
But is IDB limited to only the robotic operation, or is it also available for in-person operation?
Good question, right? I think it depends on your travel fund, right? I mean, you're welcome to here because that's one outreach, right? You have a student coming to learn not only for the structure determination, also be the bin line, right? I mean, the operation, right? And the second is yes, welcome to. I think so. I think so. Well, we are open and very welcome. The student people come here. All right. Unfortunately, we don't have a fund like a ESI support the travel, right?
Right.
But otherwise, would be. I think so. I will happy to have a student to hear and something, right? And also, I think so. When I was in the ACA meeting, right, and a couple people approached, right, so want to reinitiate the APS script, right, script APS, something the service.
Yeah.
Then we probably are going to talking to. I probably initialize some meeting and start, thinking about it, and we'll probably make a something the official program in the future, where the people can, in the different regional, right? They can have a contact person to do the service for the singleton service work, not the whole source, right? Singleton service work because it would be easier and I think the iteration for each different region and a contact person would be collect all the data. Crystal come here,
Right.
then
Right.
then in that case, if somebody want to do some, for example, want to do some heating temperature study, then we can group together, right, and get
Yep.
everybody, have a nice data set back for they need. Yep.
So in theory, scraps could be
Can be reinitiated, yeah,
could
because
start
we're
at the
working on the
beginning of
script for how
2026.
many years? but then, and we stop, but then because stop the script because we don't have much time for the
Right.
script, but now we double the capacity. Then I think so we can give it some script time, in the future.
Awesome. Thank you.
And so how long will it take to get a data set? I mean, so with it said that the beam was something like 250 times stronger. Is that the sort of thing you expect at 15 ID?
Yeah, that's just something we get stronger, but but it's stronger, right? I mean, but you don't want to saturate detector, right?
Right,
so
right.
so that's just something you probably go back to the sensing. You have to test, put some attenuation, right? Attenuator in, right? Then back to the, it depends, right? So I don't know yet. So
Right.
we will learn together, right? And see how strong the beam and what are we going to do? And also the new detector, how can we use the new detector, as a fully use of the detector to get the good data out. Yeah.
Right.
So by the way, all the detectors that you have are cadmium telluride detectors, correct? You're not using any silicon, correct?
We have a silicon. We have a one for the, we have a one, right? I mean, the ID2 line, it's a
Okay.
3.1,
Yeah.
3.5 to 31. That's what we use at Cameron. I use a
Okay.
silicon. The rest
Okay.
of we probably will keep in the Cameron telluride in the ID line. But Pilatus 4, Cameron telluride
Yes.
2N,
Yes.
the range is from 5 keV to 100 keV.
Yeah.
It's not for high energy only. It's also for low energy.
The dynamic range is like is what?
That dynamic range is probably the same, right? I mean the 10
Okay.
to the 20, right? For the
Okay.
yeah.
All right.
Hi, Yushan.
Yes. Hi, Miguel. How
Uh,
are you?
yeah, I wanted to ask if we were there, would we be able to use ID1 and ID2 simultaneously?
Yes, if you request, right? And we can, because for example, right, when you come here, we can arrange, I know probably you have an air sensitive crystal you want to use the LOBA, but you
Yeah.
also want to do some photocrystallography, right?
Yeah,
That can be arranged, but I'm not guarantee you can get a same day.
I
Mm.
see.
Okay, so for photocard maybe get a 2 or 3, but for the LOBA you may only get 1 day. I don't know. We have to exercise a little bit and see how that works.
Yeah, yeah, because a lot of time could be, it takes a lot of time to do the photocrystallography, so we
That's
could
right.
get through
That's right. I
sample.
know. Yeah, we know. I mean, we all know, right?
Yeah.
So, but somehow you want to maybe you want to screen some crystal, you want to transfer to some, but that's doable. I think that's doable. Then we have to discuss in detail and how can
And
arrange the time schedule for the. But then you need to have more manpower when you come here, right? You cannot.
Yeah.
You have to bring your
The
army to
problem.
here, right?
Yeah.
So
Good.
Go ahead.
Yeah, the other question I had was about the serial
Crystallography.
crystallography. Is that serial photocrystallography or just serial
Yeah,
crystallography?
I mean that's something we are working on. I think so. Jinxin is the one, right? Working on the FPGA, right? We try to have a laser, right? Shoot.
Yeah.
Then we can and also collecting. It's ongoing project. That's what we have a time result. Once we have a serial crystallography done, then we can turn it on and off or something. Pop, depends. That can be a lot of things can be done.
Yeah. All right. Thanks.
So I had a question about the robot. So the robot is going to enable you to like set up a macro and, for example, put a sample in and then change temperatures. Can you change temperatures with the robot?
Yeah, because LOBA
Yeah.
normally, right? I mean, would be sit in the low temperature device, right?
Yeah.
And the low temperature device then can be set up in the variable temperature as well.
Okay.
Okay,
You can program it to do multiple things. Okay.
Yeah. But
excellent.
that is something you have to request, right? Because normally we set up temperature for low, but
fixed temperature.
You say
Yeah.
you want some variable temperature, then we have to set up in different way.
Okay. Great.
Other people question?
Hey, Yusheng.
Hey, Ian.
Do we have any idea on how the new beam intensity and shape will affect in situ measurements in terms of increased background from capillary shields and things like that?
You mean the background, right? Captain shared the background, everything?
Yeah, like we're using the capillary shields for the gas flow experiments and things like
Yeah.
that. Do we expect a higher background, and do we have maybe a plan on how to address
That depends
those?
on the energy, right? Of the X-ray you use, right? I mean, of course, you're the low energy, you see the older background coming out, right? But if you go to, but then the good thing, right? I mean, the high energy can be focused, right? So eventually, I don't expect that much background for the high energy, especially for 40 keV or something else.
Okay.
Right. Yeah.
Awesome.
Other question? Anything else about no? About
I had one more about the inline spectroscopy.
okay.
Is that photoluminescence or can you do absorption as well?
Yeah. Yes, we can do that. Yep. Yeah, we can do that.
With the double the beams, what do you see is likely going to be the scheduling of each sector?
Good question. Good question. Yeah.
Can you repeat again? I didn't. So if you
Sure.
double the bin capacity, right? So what?
Right.
And-
So back then, I recall the scheduling was split in 3 different sectors, but now with 2 beams, does it potentially mean that we may have twice as much time for a specific experiment that we were looking for?
Are you sure? Are you sure? I mean,
I
that's
hope I'm
my.
not the one doing it.
I don't think so, right? Because people never certify, right? I mean, even for us, right, have a double the bin, right? I mean, we have a lot of things can be tested before we are limited.
Right.
We put a user as a priority. But now, I mean, if we're still testing, right, exercise, once we double the capacitor, and we don't know what's going on, but hopefully we can try keep it 5% or something for develop the new technique, right? But not, but I doubt it because everybody, when get a very, what do you call, when get every robust, smooth,
Right.
right? The user wanted every single piece of the bin time.
Yeah.
Right. I mean, that's a no doubt, right? I mean,
True.
you know that, right? But
Right.
we see, but we try to probably, yeah, we try to. That's why another thing for the 3D Delta PDF, right? We didn't put that much effort in, right? We don't have enough bin time to do it. So because also we see the request is only for physics or for certain, right? The community. The last, I'm not discriminate, but then we have to see what are the best for the big major community.
Yeah.
Then that's how we decide how to do the development.
Yeah.
Thank you.
Any other?
Hi, can you hear me?
Yes, I can hear you.
I've got a question. The Oxford N-Helix cryostream, is that going to be available on a particular beamline, on a particular hutch, or is that transferable between the two?
That would be I would say, yeah, I would like to put in the ID1, right? But if needed, we can transfer to the ID2. For both hatch, we set out the power and everything. And I think so we need to transfer would be also have a cylinder already set up. then only we need to transfer is the compressor. So that's something we are thinking about, right? We want to sit in the one hutch, but if you need it, we'll try to make a portable, can go to another hutch.
I see. And
Because
the robot will be in 15 IDB, which is
Yeah.
the global
ID2.
will be IDD2, right? Like, and fixed, and the energy will be, I think so will be 20 to 30 keV at some point. That kind of, keep the high energy, get a high resolution. And the detector will be plus 2M, large detector. Yeah. And normally operate with the heat, nitrogen temperature. But we need to see, if we want to go to the helium, we'll see how difficult is swap up and also the dimension, the space. Can we have the lower bar, the grip can go into change it simple, easy, or that we have to look at. That's something. Yeah, well, I would not say yes, but we have to try and test. Yeah.
I see. Thank you.
Any other question? Need a more technique problem? You need to know? Yeah, I probably announced, right? We try to, get the morph community, get involved and see what they want. So I would be probably host some, get a more workshop, kickoff meeting, right? And see, looking for, listen to the morph community need, like for the in situ characterization and something what we can really do right now. Because before we have we don't have enough bin time. Right now we double the capacity of the bin time. So we can really thinking about the real and good stuff coming out. Before it's just okay, we do this, we do that, but now we can really, focus some direction and working on it.
Actually, I've got one more question,
Yes.
if I can. Is there a capacity to align crystals? If you've got a kappa goniometer, you get the unit cell, and would you be able to specify a given alignment for the crystal after you found the orientation matrix?
Yeah, I think so, right?
That?
I think that would be I think that we should be able to do it, right? The orientation matrix. My philosophy, once we get a good orientation metric, we should be able to get a data set, right?
But the question though is whether or not you can rotate about a specific axis, say the C axis, once you've gotten.
You want to go to the orientation, right?
Right.
I think. I apologize. I have to look at the new diffractometer, right? The new diffractometer maybe can have a copper arm, right? Can be aligned axis.
Right.
I guess. Okay. So I have to double check because we have the crate is sitting on the floor. I haven't opened it. We'll have to test. So that's something, I apologize. But yes, I have to look at this problem because a lot of people want to say, okay, can we do something in the certain axis located, right? And get some, feature or correlation come out, right? And like a 5-axis, the big 5-axis of skin. Right? See the profile of the diffraction or something. I think so that the new diffractometer should be able to do it, but I have to double check because that's why the one new diffractometer I asked for because it's a copper free, can be aligned. So yeah.
We want to mimic the old style oscillation images, right? As you've seen over on 14 BMC, right?
Yeah.
Is it still going to be Brooker Apex diffractometer?
No, we have we actually keep the Brook as diffractometer we probably put in the storage right now, and we have a Huber three-circle copper. Then we convert. Then we converted the CBF to the Bruker software.
Right.
Yeah. That's how we've been doing right now. And also, I think so the people doing a lot become very common right now, right? After we do it, right? So people they have a software can convert the CBF directly to the SFRM
Yes.
Bruker format, right? I mean, it's a become. I mean, knowing everybody try to do it now, so it's you know. So that's why I say when we do that, right? We should probably publish one paper, right? And that would be the difference, right? Any question? Otherwise, we might have to go to the. I don't know when the breakout section will be done. Then we'll have to go to the total section. So any other technique problem you want to ask? Time? Or you don't thinking about, you might can send me an email, and we can discuss and and yeah.
Okay.
So next May, right? If I remember, we mentioned right in next May 2026, we'll have a workshop in person, right? So yeah, welcome everybody joined, and yeah, we probably will post the day very soon, and yeah. Any question? More question? No? I mean, our co-PI, Tad and Jason's here, and yeah.
You guys are doing an awesome job. Keep it up.
Yeah. Good luck.
Yeah.
A lot of work.
A lot of work. Yes, I agree. I mean, a lot of work. Yes.
15 months. Jesus.
I mean the new staff, very, very helpful, and yeah, so we can think about more stuff coming up, right? We have a lot of things to do, I mean, we have a lot. Yeah. And welcome everybody want to join, do some collaboration or something else. Welcome. Be free. Feel free to contact me. Then we can find something, right? I mean, yeah. We need your support and also your idea. All right. And then we can make the program better and then go forward. Right? Yeah. Any more question about?
One quick question, and that is, how much free space will there be around the goniometer head for doing things like pressure or electric field studies? I think we've talked about those sorts of things.
Yeah, that's a good question, right? Because in the IDD, right? IDD right now, the microscope, right, its focus is about I forgot. It's a 90 millimeter. So the space for the IDD is good.
Right.
And for the unaccessed, like a, for example, right, and here. The unaccessed camera, right?
Right.
This is a distance of 2.25 millimeter.
I see.
So this one is not good for the in situ, like you have something actual chamber, right? And yeah. And by saying that, right? I mean, Mark, you're probably more interesting because I'm talking to we try to collaborate with the sector 14 for the electric field study. Right. I mean, you probably want to get it, get involved at some point.
Get what? Get what at some
Get involved, for the electric field study. Yeah. I'll probably send you more information.
Great.
Yeah. So this is the kind of I think it's less than 1 kilohertz data collection. Yeah. Yeah, you can see that movie. For each dot is a simple, about 20 micron, and dot spacing is probably 50 micron. Yeah.
Interesting.
Yeah, so that's collecting data. Yeah. So then we try to start in process the data with the crystal field, and we'll see. And the crystal field have an update version, so we'll see how that works, and continue for the the serial crystallography.
Great.
Any other technical question we can study here or resolve here?
Sounds like you answered all the questions. Great job.
Yeah. If not, we can go into, we can go back to the main. What time? Jinxin, should we go back to the main section, right? Yeah, thank you everybody, right? And we'll probably go to the main room to continue the close
Thank you,
section.
Yuxing, for all your hard work.
Oh, thank you.
Thanks so much.
Thank you for your support, right? My dear user community, right? I mean, that's a really, really very good support for last, how many decades? 2 decades? Yeah.
More.
Yeah.